Okay. All right, guys. Quick video. First, let me start off properly. Namaste. Quick video on section 11.2. Some of this you're already going to get through the last video that you did on distance and time graphs. But when you read this section of the book, 11.2, you'll read about some of that stuff again. So it should be somewhat familiar to you. But one of the main things that section 11.2 talks about is the concept of speed and velocity. And they're like each other, but they're not quite. We've been talking about vectors, and I introduced the concept with the concepts of distance versus displacement, and how distance is a scalar quantity. Scalar means it doesn't have a direction to it. So distance is just simply how far you go. It's like 50 miles. Displacement is a vector quantity. It has a direction to it. So 50 miles due east, it has a direction to the 50 miles. That suddenly becomes a displacement then, or a vector quantity. Vectors have size or magnitude and direction to them. And there's an analog with that, and that lies in the concepts of speed and velocity. Speed is a scalar. It's just a number. It just tells you how fast you're going. Velocity is how fast you're going, but in what direction. So, for example, and I'm going to just go to this slide right here. All right. So, for example, oh, I got animations on there. All right. There we go. Okay. Actually, before I go into that example, let's take a look at these. Speed, obviously, is how fast you go. Right, in a given amount of time. You could talk about two different types of speed, obviously average speed versus instantaneous speed. And an average speed is kind of what it sounds like. You calculate it by taking the total distance you traveled divided by the total time. And it's actually pretty simple. So, and Americans kind of do this stuff all the time because we're in cars and stuff. So let's say you travel 100 miles and you traveled 100 miles in 2 hours. So it took you 2 hours to go 100 miles. What would your average speed be? Well, you would take the 100 miles divided by 2 hours. 100 divided by 2 is 50. You would have had an average speed for that trip of 50 miles per hour. Now, that's your average speed. That doesn't mean that you were going 50 miles an hour the entire 2 hours. You probably weren't, because if you're on I-95 or a highway, you're probably, going 75 miles an hour for the most part, but then you hit traffic. So then your 75 miles an hour goes down to 30 miles an hour. It might even be a dead stop at times. Okay, especially when you get near Boston. But still, if you go 100 miles in 2 hours, your average speed is 50 miles an hour, not your speed at any one point in time. Your speed at any one point in time is your instantaneous speed. So along that trip, even though you averaged 50 miles an hour, when you were traveling at a certain point, you were going 75 miles an hour. That 75 miles an hour was your instantaneous speed at that time. Okay. All right. On a distance versus time graph, this is also in the last video. When you're moving at a constant velocity, that shows up as a straight line. All right. If you're going forward, it's a straight line going down. If you're going back, and also that the slope of the line tells you how fast you're going. And I think I have that in the next slide. Okay. Well, not in this one. All right. Let's answer these. Okay, with respect to that. So here's a position in time graph, and you guys already did some of these. When is the object not moving? Well, when you have a flat line. Okay. How far away is the object when it's not moving? Well, you can just read that off the graph in this case. So 10 meters, looks like we got a flat line when you're 20 meters away. Okay. Where's the object moving forward? Well, here it's moving forward. You have a positive slope right there. Another positive slope. So it's moving forward here and it's moving forward here. Don't be fooled. It's not moving at all over here. Time is going, all right, but you're not moving forward or back in space. Where's the object moving back toward the start point? Well, that would be right there. Negative slope means you change direction and you turned around and you're going back. Now, again, you can't do that. You can't, let me do this again. Look at the cursor. You can't do that Why? Because that would mean you're going back in time. So going back is a negative, so it looks like this. Why? Because time keeps clicking forward. All right. Your math teacher taught you that slope is rise over run. So again, if you take the slope of a line on a distance versus time graph and you calculate that slope, all right, that will actually tell you how fast you're going. So if you take a look, look at these 2 points right here between 0.1 seconds and 0.2 seconds. You have a rise of 20 centimeters. So at 0.1 seconds, you were at 20 centimeters. 0.2 seconds, you would have moved to 40 centimeters in that time. And so you have a rise of 20 centimeters in a time of 0.1 seconds. All right. So 20 divided by 0.1 is 200. So your speed actually is 200 centimeters every second. Okay. And that's how I calculated. I took the slope, which is the rise over the run, just like your math teacher taught you how to do, except in this class, instead of y's and x's, we have distance and time. Okay. All right. Velocity is, all right. So it's a vector. Speed with a direction, I already said that. So for example, speed is 50 miles an hour, but a velocity might be 50 miles an hour, 30 degrees north of east. Okay. Where would you want this? Well, certain vehicles, like I said, want you want a velocity rather than a speed. When we're driving in our cars, we get by with speed because we can see where we're going. But if you're in an aircraft, especially at night where you can't really see much of anything, the tower needs to call into the aircraft a velocity, and the tower will say, make your airspeed 500 knots at 30 degrees north of east or something. So the aircraft needs to be given a velocity. In fact, the term is that the tower, they say they vector the aircraft, okay, because velocity is a vector. All right. Okay, I'm going to stop here because these are questions to ruin your self-esteem and make you feel bad about yourself. And you can answer those because I'm going to send you this slide, these slides anyway. So, all right, let me get this out of here. Okay, exit. And all right, so take notes on this video and then read the section and then do the worksheet on the section, then get that back to me. And as always, come and see me during my office hours if you have any questions. Okay? All right, goal us out and enjoy your apocalypse.